Hi, my name is Whitney Gilman, and I chose to do my project on the Playfair cipher. I picked this one because I think it sounded fun and interesting, and it has the word play in it, so I was hoping to make math just a little bit more fun and playful. So, a little bit of history of a background on it. It was invented in 1854 by Charles Wheatstone, but it has the name of Playfair because of Lord Playfair, who kind of initiated the use and who started the progression of actually using it, and so it's kind of named after him now. He was a British scientist and a liberal politician. It's also known as the Playfair Square, which I will explain in a second, and it kind of makes sense as to why that is, or the Wheatstone Playfair cipher because they both kind of shared it. It was used primarily by British forces in the Second Boer War and in World War I, and then it was continued in the use of warfare in World War II by British and Australian forces. And the reason that they used it is kind of because it's easy to use but hard to decrypt if you don't know what it is. So they said that they can teach it to a schoolboy in about 15 minutes, and that was their reasoning. So by the time they got it and decrypted it, it was useful to them, but by the time that the decryptors tried to solve it, it was already too late for that and the moves had already been made. So as it goes for cracking the code, it's no longer used just because the advancement of technology, and technology is kind of so common and is so much more advanced that a computer can solve this in like 5 minutes, but back in the day when people had to do it by hand, it would take them a longer time. So obviously it's not really used much anymore, but it was still a good kind of asset at the time. And the first published solution was published in 1914, and it was like a 19-page pamphlet that kind of showed the discovery of how to solve it and how to crack it. It's perceived to be very complex, but once you get the hang of it, it's super easy to pick up. So as it goes for the actual breakdown, so basically it's a table. You remove the letter J and you insert the alphabet after a keyword. So for just the sake of this example, we will just use the keyword, and you kind of just fill in a table after you do that. So 1, 2, 3, 4, 1, 2, 3, 4. So you write keyword, and then A, B, C, and then you take out the letters that are already used in the keyword. So it would be A, B, C, F, G, H, I, L, M, N, P, Q, S, T, U, V, X, Z. So then you pick a message from there. So let's just say, for the sake of making this easy, our secret message will just be secret message. And then, as you see as the rules part 2, you put all the letters in pairs, and then you separate any double letters by the letter X, and any odd number you also insert a letter X. You ignore all spaces, and then you also, so you break the stuff up into pairs. And so instead of being secret message just like that, it becomes SECRETMESXSAGE. So that, and you ignore all spaces, and you ignore all of the fact that it used to be 2 separate words, it's now just 1. And then, as it comes to decoding it, you follow these 3 rules, and these are kind of the key. So if they're in the same column, you move each letter down 1. If they're in the same row, you move it to the right 1. And then anything other than that, you just make a square around it and then follow the rule from there. So that's going to be the most common that we'll see, and that kind of changes everything, and then that's how you do it from there. So taking this message, SECRETMESXSAGE, you kind of take those and then just follow the rules from there. So SE is the first 2, and S is right here, and E is right here. So what you do is you make a square around this, and then you just follow the rule, which would be swapping it with the letter that's farthest from it. So S becomes N, and E becomes O. So the first 2 letters instead of SE become N-O. And then the next 2 in the sequence are C and R. Once again, these are actually in the same row, so what you would do is just scoot it to the right one. But since C is on the end of the row, you just take this and you put it over here. So C would become R, and R becomes D. So that next 2 becomes RD. And you kind of just follow that. It becomes easier as you get going, and you can kind of figure it out from there because it all tends to follow the same things. Same thing again, the next two are E and T. You do the square because they're not in the same row or column. E becomes U and T becomes K, so the next two are KU. So you follow that from there, and it kind of, if you do the whole message, it takes a lot longer, but I think it's kind of self-explanatory, and you just do it all from there. I have it pre-solved out on my paper, and it makes the final answer out to be NORD, KU, NK, QZ, PC, and D. And then these are split up the same way that these are split up, but once you fully finish decoding the message, you make it all just one word, which basically you just combines these, and it makes the message out to be like Nord, Kunk, Kuzen, and that's the final answer. So you just take that, and then you send it off. I have a lot of fun doing this, and I think it's super easy. Like I said, not really used for military reasons anymore because, as you've seen, it's super easy to encode. And then as it goes for decrypting it, you just take the same process and you just reverse it. So if the letters are K and U, I'd say KKU, swap it, it becomes TE. So that's actually how it would be. So that is how you solve it, and that is Playfair Cipher. Thank you.